Hello everyone, welcome to the course Data Science. Today's topic is how to handle missing values. With related to this, we had seen how to handle huge volumes of data and what are the problems or what are the challenges and what are the solutions, what are the general tips. Then after that, we have seen what is data wrangling. So in that data wrangling, we have a few techniques, which is discovery. We have to discover the pattern in the data. Then you have to structure the data, structuring. Next one is cleaning. The next one is enrichment. Next one is validation. And then the last one is publishing. So these are the steps so that are for data wrangling. So data wrangling is conversion of raw data into a usable format. Okay. So in this, in cleaning. So in cleaning means you have irrelevant data, you have missing data, and you have null values data, and you have inconsistent data. So you need to clear this. You need to clean this. So for that, this cleaning method is used. So in that, one of the topic is missing values. So we are going to see that topic in this lecture, how to handle missing values. Already in the last lecture, we had seen data enrichment also using merging, concatenation, and combine first. Using that, we can merge two important data sets for data enrichment. And today's class is about how to handle missing values. So this missing values is under cleaning technique. This cleaning is under data wrangling. So data wrangling is conversion of raw data into a useful format. So let's see what is or what, I mean, how do we get missing values and how to handle missing values? Okay, so missing values are the data points that are absent for a specific variable. Okay, it can be represented in many ways. One is blank cell or null values or special symbols like NA or N unknown or NaN also. So this is one example. So these are the missing values. Okay, so why is it important? Suppose if you have any missing value, and then that missing value, any data could be there. So if you don't, I mean, impute the proper data, then your quality will be highly affected. So that is why handling missing values are very important, because it affects the quality very much. Okay. So since it affects the quality, automatically your performance will be deteriorated, because we can take one example. Generally, in any forum, they always rely on feedback. Okay, we'll take like A, B, C, D, E. So these are the five guys. With these five guys, they have asked some questions. So nearly five questions have been asked. So A answered three, okay, out of five, and then B answered two out of five, and then C answered one out of five, and then 5 answered 5 out of 5, and then E answered 2 out of 5. Okay, this is some data. So in this, you can predict this, because 3 they have answered. So from that we can predict what is in their mind. But it's very hard to predict. It is very hard to predict. But this is okay. But it is very hard to predict, which means these data has missing values. So in this, it's very hard. It's because it's only one only they have answered. So instead of imputing the other four values, better delete it. So you can delete it. So this is how you can handle the missing values. Or if you have two out of 5, means either you can delete or you can fill the missing values. Okay, so this is how we are handling this missing values. So suppose, while you, I mean, the missing values can be handled in two ways. One is you can delete it or you can impute it. Okay, impute means you can impute with the mean or median or mode or any forward fill or backward fill. So using these techniques, we can impute it. So these are the two solutions: either delete it or impute it. So when you can delete, if you have more missing values for a particular case, in that case you can go for deletion. Or if you have one or two only missing values, means in that case you can go for imputation. But in both the ways, if the imputation is not proper, or because you have deleted, see, for example, here 1 out of 5, even if you are deleted, this one data is missed. So this will affect the quality very much. So that is why it has to be handled properly. So the data quality will be affected. As a result, if the data quality is not good, then we cannot predict the model. So the model performance also decreasing. And if you have bias value in the sense, for example, your temperature reading is 30, 40, sometimes 120, and again 30 or 42 and 36. So in this, so this is the outlier, or so if you have this kind of bias also, it leads to the data quality will be very poor, or the model performance will also be deteriorated. So here in this case, instead of missing value, you have irrelevant data. Okay, so that has to be addressed. So in this way, a bias works, and then data loss. So in order to handle missing values, one procedure is deletion. So while you delete the rows or columns, some important data may be missed. So you have significant data loss. Okay. And finally, the interpretation. So missing values can make it difficult to interpret the result of your analysis. So these are the problems. So that is why it has to be handled uh, properly. So that is why it says it is very, very important to handle missing values. So what are the techniques to handle missing values? One is deletion, another one is imputation. So deletion means if you have more missing values, then you have to go for deletion. Imputation means if you have less number of missing values, you can impute a different value instead of leaving it unknown value, or instead of leaving it nan, or instead of leaving it blank, you can fill it with some known value or customized value or some known value. So these are the two techniques to handle missing data. One is deletion and imputation. So let's see what is deletion. So in deletion, we have two techniques. One is either go for list-wise deletion, either or pair-wise deletion. So let's say A, B, C, D. So they did not answer this, they did not answer this, but they answered, they did not answer. So they did not answer, they did not answer, they answered only one. And then this guy answered everything. Okay, and then this guy answered everything, and only one is missed. Okay, so in this you have three missing values. In this you have four missing values, and then here is zero missing values. See here only one missing value. In this case, since you have more number of missing values, so you have to go for deletion, and since you have only one missing value, you can go for imputation. And even in this deletion, if you have more number of, see here you have more number of missing values. In that case, you have to use list wise deletion. Okay, so remove entire rows or columns containing missing values. This method is simple but can result in significant loss of data, especially if there are many missing values. Whereas pairwise deletion, it removes a pairs of observations where at least one value is missing, and this is less wasteful compared to the list wise, because the entire row is not deleted. For example, in this row, only these two are deleted, or only this particular one is deleted. So that is called as pairwise deletion. So let's see one example. Let's take list-wise deletion for customer feedback analysis. So here, first we have to frame the data frame. So in the data frame, your columns are customer and the satisfaction and feedback. So here, customer satisfaction and feedback. And since the index is not mentioned, so the index is default 0, 1, 2, 3, and the customer ABC satisfaction and feedback. In this you have nan here, and then you have nan over here. Okay, so now in this, which row has got more nan means the zero, so that has to be deleted, because even if you delete, it will not affect because you don't have any useful value in that. So how do you do this? So your data frame is data dot drop na. Okay, so in this, wherever you find na, so that row should be dropped. So that is the meaning of it. So this, now it is clean. So now this data is clean, it is free from NaN value. So this is one kind of approach, which is list-wise deletion. So let's see one pair-wise deletion. So here one data frame, which is date, stock A, stock B, and the index is not there. So the index is given by default, and these are the column, and then the date is fixed by this function date range. Start date is given, periods is also given. Okay, since periods is given, so we know that. And then here the duration frequency is not given, so it is usually considered as a day. So this is first and second, third, fourth, five. So this is the data frame. Now we need to apply, which means I have to apply pairwise deletion. So which is called as correlation. If you apply dot correlation and we are applying Pearson method, in that case you will get one data and then that data is of correlated ones. So for example, so here in correlation matrix, all the diagonal values are always 1. If it is closer to 1, then that is called as positive correlation. If it is closer to 0, then that is called as negative correlation. Here, all the values are positive correlation only. So when you apply pairwise deletion, when you can pairwise deletion means when you want to find the correlation between. So in this example, if the date increases, stock A increases. So that's what it shows, positive correlation. If the date increases, stock B is also increasing, that is why 0.98. Okay, here then if stock A increasing, your date is also increasing, or your stock A increasing, stock B also increasing. So in order to get the relation between two different icons or two different entity, in that case you have to go for pairwise deletion. So if you apply pairwise deletion, this will be deleted and then the Pearson method is applied and then we'll get the correlation matrix. So this is one way of handling missing values. Okay, so the next method, we'll see forward fill and backward fill. So let's see an example. So here we have generated the date, and then here the frequency is hour. That is why first starting with 0 hour, 1 hour, 2 hours, 3 hours, 4 hours. So we have generated the index as well as the entity, I mean time entity. Next one is temperature, that is given already. So you have nan over here, nan over here. Okay. So up to this is a data frame. So now I'm going to apply one technique, that is data temperature. That is in the data, I have to take the temperature column. In the temperature column, I have to apply forward fill. Forward fill means it has to move like this. That is, your 22.5 is here and the next value is nan. So your 22.5 is moved to nan. That is called as forward fill. So after forward fill, so 22.5, 22.5, and then here one nan. This 23 is moved to nan. So 23, 23, and then the other value is 24.5. So this is called as forward fill. Whereas backward fill, so here 22.5 is already there and then nan, but 23 has to move like this. If 23 moves like this means that is called as backward fill. So this nan is replaced by 23. Okay, so here 23, 22, then 23 is already there and 24.5 is moved back. So that's why 24.5, 24.5. So this is called as backward fill. This is called as forward fill. So in this way, instead of deleting the nan values or nan row, we can impute with some logic or some values. So in this, we have taken forward fill and backward fill. The next method is imputation. So while handling nan values, we can use either deletion method or imputation method. Okay, so in imputation method is process of replacing missing data with estimated values to maintain the data set integrity. So we can fill it with the mean or we can fill it with median or mode, but the knowledge we should have is when to use mean, when to use median, and when to use mode. Okay, so we'll see this. So if you have your data is normally distributed, in that case you can, if you have any missing value, you can fill it with mean. Okay, for example, if your data is like this skewed, or if your data is skewed, so in this case you have, this is the mean line, so it is far away from this mean. So here we cannot predict. In this case, you have to use median method. So let's see one example. So in this example, 10, 12, 13, 14, 100. If you take the mean value, it is 29.8. If you take the middle value, it is 13. So we ourselves know that which one is closer to the data, 13. But 29 point is far ahead because of this outlier. So whenever you have outlier in the data, in that thing, instead of filling or instead of going for mean, you have to impute with middle value, so, or median value. So this is called as imputation. So imputation can be done using mean value, median, and mode. So when to use median? When to use median? When you have any outlier in the data or when the data is skewed. This is called as skewed. When the data is skewed or when the data has outliers. So when the data is skewed or when the data has outlier means in that case you have to use median or middle value, because the skewed will not give the proper, I mean, if you take the mean for the skewed value, it will not be proper. It will be far ahead than the normal values. That is why in skewed data or outlier data, you have to choose the median. Then if it is a normally distribution, then you have to go for median. And if it is a category, suppose if you want to categorize particular data, then you have to use mode. Okay. So imputation means the process of replacing the missing data with either mean, median, or mode. Mean means it should be normally distributed data. If it is median means it should be either skewed or it has outliers. Mode means it has a category. So accordingly, we have to impute the data for the missing values. So let's see one more example or one more type, which is k nearest neighbor. So let's say this color, this shade is one class A, and then this shade is class B, this shade is class C. So here this is my unknown. So for this, I need to find whether this particular category belongs to A or belongs to B, belongs to C. Okay, so what generally we'll do is we'll use either Euclidean method or Manhattan city block method to calculate the distance. Let's say this example. So it will calculate the distance, okay, from this point to D1, D2, D3, D4, and here also. So based on the distance, this is arranged like this: D1, D2, D3, D4, or ascending order. We can say ascending order. So we'll select some 7 data. Then accordingly, we choose one particular data and you have to fill it. So that is called as k nearest neighbor imputation. So this can be done easily in Python. So in this case, first you have to find out what is the distance between that particular point and the other elements. Then you have to find out the distance, arrange it in the ascending order, select first few distances. In that, you have to take one particular value, use that particular value to impute it. So that is called as k nearest neighbor method of imputation. And another one is regression imputation. Regression means, for example, if you have data like this, the data are scattered. I want to model the data. So for that, I'm going to use one regression line. This equation could be a into x1 plus b into x2 plus c into x3, and it goes on. So we have to find a, b, c. So this a and b and c is determined from this regression line. Then that value has to be imputed in the missing value. And multiple imputation, it could be many things, like different values you can impute it. Okay. So one example, we'll see what is that imputation techniques. So in this imputation, you have to use scikit library. So scikit learn. From that, you have to use impute object. So you have to impute simple imputer. So this has to be must, because whenever you want to impute it. So this is one data frame. The data frame is patient and blood pressure, and then the index is assumed by itself 0, 1, 2, 3. So here patient 1, patient 2, patient 3, patient 4, and then the blood pressure is 120, 115, and then none, and 130. So this is the data frame. This data frame name is data. So this is the data frame. So now I am going to apply this simple imputer, which is already imported from this. So simple imputer, I'm going to take the mean value. So if you find any missing value, then you have to replace with the mean value. So that is the logic. So that imputer you have to call. So whenever you call this imputer, which means it has already calculated the mean, and that mean has to be replaced. And then dot fit means you have to calculate the mean for the NaN value. So this is called as imputed dot fit. Imputed dot fit means it calculates the mean from the non-missing values. Then transform means your transform will replace the missing values with the mean value, and then on which you are going to apply on data frame in that blood pressure column. So you are going to apply on blood pressure column. What you are going to apply? The transformed data. What is the data transform? That is the NaN value or replaced with mean. So that operation should be done on the data frame data. On that, the column is blood pressure. So this is how it works. And then the next example is, so here we have 3 columns, and then the data frame name is data. So this is the sorted one. So let's take, yeah, we have product, we have category, we have rating. and product you have A, B, B, and then category you have electronics, clothing, and the rating is 4.5, NaN, and 3.8 and NaN. Okay, so in this we are going to use imputation method. So how do we do this imputation is, first you have to take the data. So data means data frame. On this data frame, you find the missing values in rating column. So you have to address this. So in data frame, you have to take the rating column. On that rating column, you have to fill NaN value. So in rating, wherever you find, you have to fill. What you have to fill? So before you fill it, you have to do this. That is in data frame, in that you have to group the category. So what is the category here? This is the category. In the category you have electronics and clothing. So first you have to group it. So group electronics separate and group clothing. So first you have to group it, and then once you group, automatically the rating will also be grouped. So you take rating column, and then on the rating column you have to take the you have to do the transformation. So in the transformation, you're going to replace with mean. So in this 4.5 and then this is 0. So the mean value is 4.5. So 4.5 is imputed. And then in another group 3.8 and this is no value. So in that 3.8 is the mean. So that has to be imputed. So this is how imputation is done. So again, I'll repeat. So this is the data frame. That data frame name is data. In that you are going to use only rating. So the rating column is chosen. And then what you're going to do with that rating column, you're going to fill the NaN values. So how do you fill the NaN values? Before you fill the NaN values, you have to group the data frame, the category column. So you have to group the category column. And then once it is categorized, the rating will also be categorized. On that rating, you are going to transform the data. That is, if you find a NaN value, that has to be replaced with the mean value. So this is one kind of imputation. So, so far we had seen how to handle the missing values. One is imputation, another one is deletion. Deletion means if you have more missing values, then go for deletion. But if you have less missing values, in that case, you have to impute it. Or it's not that you have to impute with only less missing values. Even if you have more missing values, if you're confident about the discovery of that data, then you can go for imputation. So in imputation, we can impute the data with the mean or median or mode. So when you have to choose the median, if you have outliers or skew data, and then for mode means the data should be categorized, and if it is mean means it should be normally distributed. But whatever it is, you have to choose the right approach to deal with NaN values. So one is whenever you do the right approach, you have to consider this. First, you have to find it out how many data are missing, what's the amount of, what's the number of missing data, and then how it is distributed. Suppose if it is a big column, so here NaN value, here NaN value, here NaN value, here NaN value. So this is a distribution. Or you can take one more data frame. So you have missing values or like this, missing values, and then here you have data, here you have data. So this dash is called missing values. So you have to find out that how the missing data is distributed, and you have to find out the impact also, the impact of the role of missing data on the analysis. You have to consider these three, and you have to go for handling the missing values. So that's all for today. So in today's class, we had seen how to handle missing values. This is very, very important for a data scientist. If you don't replace the missing, or if you don't fill the missing values with proper values, then it will affect the quality. In that way, it will affect the model performance, and then more data loss would be there. Finally, because the data science is for model prediction only, so finally the goal is not reached because of mishandling of missing values. So that is the takeaway point from today's class. Thanks for watching.